Problem solving is a major form of thinking where we are trying to take the steps to solve a problem that we're faced with in our environment. Now, we can look at problem solving strategies that humans and other species use, and one of the most basic forms of problem solving is trial and error problem solving. Now, as the name implies, trial and error problem solving involves trying one solution after another until you find something that works. Now, this can be very time consuming. If there are a lot of potential solutions, you may have to try many of them before you stumble upon the correct solution. This can also be a dangerous way to solve a problem. So if the problem is something that's dangerous or there's the potential for injury, you don't want to have to try every single solution and experience the consequences to find the right answer. Just to give you an example, you wouldn't want to have to use trial and error problem solving to find out what plants in your environment are safe to eat or what fruits are safe to eat. When you're driving a car and learning how to drive, you don't want to have to just get in the car and learn through trial and error. We do learn through instruction from driving coaches and going to driving school, reading the driving manual. But again, you wouldn't want to purely be learning how to drive based on trial and error by crashing the car 16 times or something like that. So trial and error is one way to solve problems, but it can be time consuming and it can be dangerous depending on the exact problem that we're trying to figure out. Another major form of problem solving is the use of algorithms. Algorithms are specific step-by-step instructions, and if we follow those steps precisely, we will get the outcome or the result. So a good example of an algorithm is a recipe. If you follow the instructions exactly, you should get the cake or the meal that you're trying to prepare. And you may know that if you sort of deviate or fudge the recipe in any areas, you may not get the same product at the end. Okay, so if we follow those exact instructions that are precisely laid out, we usually end up with the result. Antivirus software on your computer is another example of an algorithm. When you run an antivirus scan, that software is running through specific steps and procedures to detect anything dangerous on your computer and give you the options for eliminating it. So algorithms are specific step-by-step instructions. Now, humans also use what are called heuristics to solve problems. Heuristics are the opposite of algorithms. These are quick mental shortcuts where we sacrifice precision for speed. Okay, in the reading below, you're going to learn about a couple of different examples of heuristics that humans use. Okay, but overall, these are really quick mental shortcuts that don't always give us the right answer, but they are really fast, they save time, and sometimes they are correct. So in the reading below, you'll learn more about trial and error problem solving. You'll learn more about algorithms. You'll read a little bit more about heuristics and some of the different mental shortcuts that we use. And you'll also be introduced to some of the barriers that prevent us from effectively solving problems. The two most well-known barriers are what are called mental sets. That's our tendency to always try solutions that have worked in the past, okay, before trying something else. This is a do what works mentality, or what's worked in the past. And sometimes it can blind us from finding a new solution to a problem. You'll also learn about functional fixedness. This is the tendency that we have to see tools in our environment in terms of their typical functions. So when we see a hammer or a nail or a ruler, we tend to think of those objects and their purpose in terms of what they're typically used for. Now there's two really cool examples. I've even posted a couple of videos of two famous problems. One is known as the two-string problem, and the other one is the candle problem. And you'll see how these problems present a challenge that needs to be solved. And in order to get to the solution, you really have to think outside of the box, outside of what has worked before, and outside of how objects are typically used in the environment. So make sure to carefully read the section below about problem solving, and you definitely won't want to miss those two videos looking at college students solving the two-string problem, and also the famous candle problem.